Hi, my name is Qaisara. I am from ISC 5A. So today I will be demonstrating how to build a simple fluid flow and thermal simulation in LabVIEW. This project shows how temperature inside a pipe changes based on flow rate, inlet temperature and heat loss to the surroundings. First, I open LabVIEW and create a new VI as you can see. And then I will add numeric control for inlet temperature, flow rate, ambient temperature, pipe mass, specific heat, heat transfer coefficient, pipe surface area, initial temperature and time step. These controls will allow me to change the behavior of the system during the simulation. And then I will create indicator. I add a numeric indicator for current time, another one for current pipe temperature, and finally a waveform chart to plot temperature versus time. And then here at the block diagram, I also will building the simulation loop. I'll place a while loop, so it will keep running the simulation until I stop it. Also, I will add a formula node. Inside the formula node, I write the mathematical model of the system. This is to calculate how fast the temperature changes and what the new temperature should be at the next step. Later, you will see. So this is the implement core math in LabVIEW. You can basically you can, there are two good options. Either you be using formula node or wire primitive. I use wire primitive. If you use a formula node, you have to place a formula node inside the while loop. So if you prefer primitive, just like me, I'll be using multiply, add, subtract, divide blocks, and keep parentheses clear. I wire all the front panel control into the formula node. Also, I wire the result, which is the next back into the shift register so that it becomes the next temperature. And then I take the updated temperature and wire it to the temperature indicator and the graph. I also update the time by adding the time step every loop and send it to the chart as well. So, to make the simulation look real time, I add a wait block. The wait time is equal to the time step multiplied by 1000. So, the loop runs smoothly and the graph updates clearly. So later, when the VI is ready, I return to the front panel and click the start button. When the simulation begins, the temperature will change depending on my inputs. If I increase the flow rate, the temperature stabilizes faster. If I increase the inlet temperature, the graph rises. If the ambient temperature is lower, heat loss will increase. So on the graph, I can see the temperature curve as time progresses. This helps me understand how the system responds to different conditions. The simulation continues until the time limit is reached and then it stops automatically. After that, I stop the simulation and save the result. This completes the LabVIEW thermal fluid simulation project. Through this project, we can see how LabVIEW is used to model real physical system using equation, loops, and graphical programming. Here right now, you can see the simulation begins. So that's all from me. Thank you so much.